All right, guys, we ready? Open up that notes package. Yeah, can you do the first one? Can we solve that first equation?
Oh, we're doing it? Okay.
Like, I can do this. So guys, you were actually doing inverses when you solve an equation like this. You add your 3x, you subtract your 12. Yeah, it's an algebraic. So when we get 20. All right, so is everybody okay with x equals 2, the first one? Okay. If we're going to solve a trig equation, which that's what we're working up towards, you have to also do some inverses here. So you could, there's not a lot of room here, but we have -4 sine squared x would equal -3. Yeah, so sine squared x would equal 3/4 square root. So sine of x equals plus or minus √3/2. Okay. If you're telling me where that happens, like if you're finding the angle from that, you are using inverses to solve that equation. Okay. But there are some rules that go along with our inverses, so we have to talk about all of that first. So let's go back to Algebra 2 here for a minute and think about what an inverse actually is. So let's write out a few points of this graph. So I know I have 0, 0, right? I have 1, 1, -1, 1, 2, 4, and -2, 4. You guys with me? That's just points off the graph. Parabola, you guys have seen that a million times. What does the vertical line test do for us? Yes. F of x is a function. So if we look at this, if we do our vertical line test, yes, that is a function. Do you guys remember the horizontal line test? Draw a horizontal line. Perfect. All right. Good start. Then what? What? Okay. It has to do with 1 to 1. What does that mean? No. So if I draw a horizontal line on this, it's going to touch my graph more than once, right? What does that mean? It tells you about the inverse. So the horizontal line is used to determine whether or not the inverse is a function. So it's a test to see if the inverse, so f inverse of x, is a function. Without actually having to graph the inverse, you would know right away that, oh, that's not a function. What is an inverse? Like, how would I find it? So I've got my table here. How could I turn that table into the inverse? Yep, so we'll go through. So 0, 0 is still the same. And then you have 1, 1, 1, -1, 4, 2, and 4, -2, right? And then that's the graph of what the inverse looks like. And it's not a function, right? Which our horizontal line test already told us that. Yes, okay. So just quick review of what inverses are in your functions. Is everybody okay with that? Questions? before we deal with it with our trig function? Okay, go ahead and put the page for me. Okay, so this, I've given you a lovely graph of sine, right? That's just a parent graph. Right here, I'm going to squeeze in, maybe I'll make it a horizontal table. Let's just think about what some of the values are on this graph. When x is 0, I get a 0, right? When x is pi over 2, what do I get for my y value? So guys, all I'm doing is looking at the graph here. 0, 0, when x is pi over 2, y is 1. When x is pi, 0, okay, you with me? What about 3 pi over 2? What about 2 pi? 0. And could I have done some of the negative values? Perhaps. Negative pi over 2, all that stuff. Okay. So that's just for regular sine. If we want to do inverse sine, we know we have to switch x and y. What do you think that's going to do to the labels on my x and y axis? Yes, so we are used to going from -1 to 1 on the y-axis. I'm now going to do that on my x-axis. So this is -1. This is 1. So what am I going to do up and down? Pi over 2, pi, okay. I know there's not a ton of room. And I'm writing really small, I'm sorry. Okay, do we need to write out the table for the inverse, or can you guys do it? We can do it in our head? Let's try. So if I'm going to use this but make the inverse, this is now my x's, and these are now my y's, right? So I'm still going to have 0, 0. And then I'm going to have over 1 up pi over 2. Over 0 up pi. Left -1 up 3 pi over 2. And 0 to pi. What do you think? Can you guys do those, the down part, the negative? Okay. So -1 is going to be negative pi over 2. 0, negative pi. 1, negative 3 pi over 2. And 0, negative 2. So what this looks like if you connect them. Is that a function? No. Okay, we want to make it so it is a function. So we're going to restrict this graph and only look at a section of it. Now, there are a lot of different sections you could pick. You want to make sure what you pick is a function and it covers every x value. So it gives you everything from -1 to 1. Does anybody think they have a piece of this graph they're looking at? Pi over 2. Yes, negative pi over 2 to pi over 2. So let me just zoom in for you a little bit here. The only part we want is that. Okay? Oh, so hard to do. And does that make sense? That's a function. Okay? It covers every piece that we would use around the circle, right? So that is the only part of the graph we're going to look at. So this is it. So we have what's called a restricted range. So the range we would use for this has to be negative pi over 2 And those are both included. You want to get those values as well. You'll also think about that in terms of your circle. You will only go from negative pi over 2 to pi over 2. All right, I want you guys to try to graph for me the inverse cosine or arc cosine. Guys, notation-wise, just realize these mean the exact same thing. Inverse and arc, they're the same notation, okay? So try and graph cosine for me. Yeah, go ahead and graph like the whole thing and then figure out what the restrictions would be. And guys, some of you turned in some missing or late homework for me. Two of them did not have names, so you guys were good. If someone wants to claim these, I can't remember that here. And then this was you. Okay. This is critical. Counts.
You know, everything comes out now.
All right, guys, walking around, it looked like most of you had this graph. Yes? Okay. What do you think? Do I want to do negative pi over 2 to pi over 2 again? Now, if I look at that section, if I zoom in on that, is that a function? No, so clearly not the piece I want to pick. What do you think I want to pick this time? 0 to pi, that sounds lovely. So, that is the section that you use. Okay. Now try graphing inverse tangent. And guys, I would definitely use these points that are pi over 4, 1, and negative pi over 4, negative 1, 0, 0. Like, I'd plot all three of those points. Okay. I'll give you a second. Really what you would be doing is taking this to be like not too bad. All right. Seeing some interesting graphs for this one.
Arrows on it. That's actually I didn't say no. I said don't see your house.
All right, guys. Does your graph look like this? Okay. I clearly only graphed one period of it. So is it pretty obvious what our range we want to use on this one is? Okay, which is from where to where? Because remember, the graph actually keeps going. There would be another section above it. Like, so what are we going to use from? So you will use. And our domain is now all real numbers, right?
Yeah.
Okay. Are the negative pi over 2 and pi over 2 included? No, they're not. But I'll just do it.
So, are you going to ask it? I think Nova is totally it's called like schizophrenia. Group like this,
Okay, so are we okay with tangent?
Yeah.
Could you graph cotangent? Could you graph secant and cosecant? Yeah, you could. I mean, think about those. We could turn, wouldn't you just turn sine and cosine into it with your asymptotes and your little parabolas here, right? Okay. I'm not going to make you graph them right now, but I want to make sure you understand it. So guys, let's look at this little chart down here. I don't like how the range and domain are written for a lot of these. So guys, let's look at this. Your tangent domain, remember we would say negative infinity to infinity. We want to make some adjustments here for an R is not a Q. And as far as the range, you look at the entire thing, negative pi over 2 to pi over 2, but you actually have asymptotes at the pi over 2. So really they should be, yeah, I mean you include it in the sense that you can evaluate the inverse tangent of when we're looking at pi over 2, but it is undefined, okay? Same thing with cotangent here, so these are going to be parentheses. Now, let's think about secant. The way that's written is just scribble these two out, they're terrible. Okay, so if you think about, I guess we're doing secant first. We just graphed the inverse of cosine, right? And it looked like this little W. You don't have to write this down. This is just a quick, make sure you guys see. So if I wanted to turn that into secant, I'd have, right, asymptotes and these guys. Yeah, you with me here? Okay, so think about your domain. What would you say for your domain? Negative infinity to negative 1 and 1 to infinity. It's what the range used to be for it, so we'll fix that on our little chart here. So negative infinity to negative 1 bracket. And I know this is small. You can't read it, let me know. I can't read it, so. And then think about your range here. Which section are we looking at for for secant? What did we pick for cosine? Which part of the graph are we using for inverse cosine? 0 to pi. So what do you think we're going to use for secant? Also 0 to pi. It makes sense that they would go together, right? So if I go from 0 to pi, that covers everything. You do have an asymptote in the middle, though. Do you guys know where that asymptote is? Yeah. So what you look at as far as figuring it out is from 0 to pi. If you were telling me the domain of the range of the graph, you would have to skip over that asymptote. So this is like what we look at as far as the section. The actual range would be 0 to pi over 2, and then pi over 2 to pi. But pi is included. Does that make sense to you guys? Yeah. Okay. I know I'm writing as microscopic as I can, so I'm sorry. Oh, pi over 2. Isn't that where your asymptote would be? Because this is 0, pi over 2, pi over 2 to pi. Come on, Tammy. Like, I will write bigger for cosecant. So, cosecant, if we thought about our graph of sine, this is what inverse sine looks like, right? So, inverse cosecant, you have, again, you don't have to graph these right now. I just want to make sure you understand. So same as sine, we want the restricted range, negative pi over 2 to pi over 2. Does that make sense to you guys? Okay, so my domain for this, negative infinity to negative 1, and then 1 to infinity. Right? The little window I'm looking at in here is this guy. So what would you tell me the range is? First, what are we actually going to use, and then what is the actual range? So we're thinking about negative pi over 2 to positive pi over 2. If you had to state the range, like skipping over the asymptote, you would say negative pi over 2 to 0, and then 0 to pi over 2. Does that make sense? Like this gives you like your viewing window, okay? And then this is what the actual range is.
So for the long version of cosecant, I just like parentheses with brackets.
For cosecant?
Yeah.
This is for
Or
cosecant.
I mean secant, I'm not secant.
Okay. Bracket, parenthesis, parenthesis, bracket. It's the same setup as this because the middle part is the asymptote. And again, guys, this is not a huge part of this. This is just to get you to understand which section of the circle we're looking at. So this is not as confusing as it's Okay, when you're ready, guys, turn the page. I'm drawing 2 circles. Okay. Alright guys, so these are both unit circles, but I'm not just being bored and adding color, okay? Like we're using a specific part of our unit circle for each of these. So think about the graphs we just drew. Which graphs did we use negative pi over 2 to pi over 2? And you can look back at your graphs if you use it. Sine. What else? Inverse sine. Inverse sine, good. Inverse cosecant. What else? There's one more. The tangent one, yes. Inverse tangent. Okay. And then 0 to pi, which ones use that as your like viewing window, your restricted range? Hopefully the other 3. So cosine, inverse cosine, inverse secant, inverse tan. Okay. All right, I'm actually going to take the time to label gradients around your circle here. So this would be pi over 6. Pi over 4. 2 pi over 3. 4 and 5 pi over 6 on that one. The other one, the first quadrant is the same, so you have pi over 6, pi over 4, pi over 3. But what do you think is happening in the fourth quadrant? Yeah, like it's not going to be 11 pi over 6. It's going to be negative pi over 6. Okay. Negative pi over 4, negative pi over 3. When we are evaluating inverses, you will give me an angle as an answer. These are the only options that your answers can be. Negative pi over 2, negative pi over 2, negative pi over 1, like all of those, or all of these. So if it's an inverse question and you tell me 3 pi over 2, you are definitely wrong. That is not a choice. Okay? These are the only possible answers you can have for doing inverses. So guys, we're actually, I know it says practice right here, but we're not going to do practice just yet. I want to do some whiteboard practice. We'll pause on the notes for a second and do some whiteboards, so go ahead and grab your whiteboard. Guys, check on the desk. There's plenty of boards and markers out right now. Some desks have like 5 markers in them. I don't know what
People so bad at these
recording boards. It's not that purple one.
What is that?
I have one.
Are we graphing or?
We're not graphing, you were just evaluating. So guys, let's do this one together. Just to make sure everybody's with me. So, inverse sine of 1/2. Since it is sine, I know I can only give answers from over here, right? So where over here does the sine equal positive 1/2? What radian value? Pi over 6. That is what you do. It's like you're working in reverse. You are telling me the angle that has a sine of 1/2. That's what's a little inverse. You are giving me an angle as an answer. Solve trig equations.
Marty, what are you?
And are you having one on Friday? I don't know. Maybe. We did do the work.
Are these beyond
All right, guys, let's try this one. Yes. Not until we get into the solving. So today, yes, yes. Yes, 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 yes. Yes, yes, yes.
Alex, if you think about it. Everything that comes out of our mouth is like
All right. Okay, so that one was easy. Pi over 6 again. Let's do negative 1.
That's not
You need to grab a marker from the board right there because I can't really read it. Yes, 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 no, yes. No, yes,
You guys don't think I'll just I'll get
Okay, remember your answer choices can only be these if it's tangent. You gave me something that is not one of those, right? Yes. Yes, sorry. Yes. Alright guys, that one was negative pi over 3. Okay, don't tell me why pi over 3. Yes, those are coterminal, but that is not a part of the restrictions that you can use here. So you've got to use the part of the circle I tell you to use. Yes, sorry. No. No. Yes. No. Yes. 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 No. You didn't give me an angle. No. No. Yes. 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 Yes.
I don't know.
No.
I don't know, man.
Yeah, is that positive? Okay, yes. Well, these are first, yes. Maybe. Okay, guys, a lot of you told me negative pi over 3. Think about it, guys. If I go into the fourth quadrant, is cosine negative? No. And you can't use the fourth quadrant with cosine. You can only use first or second. So it is pi over 3. We're doing a lot of these, guys, okay? You will get better. Let's do inverse cotangent of -1.
Now, I'm not good at cotangent, but I'll try my best.
Yeah, everyone's like, oh, now my head hurts. You can do this. Yes. What? Yes, yes, no. No.
Why didn't you say
Yes. Yes.
no, why didn't you say
Oh, I looked at it wrong.
Science.
No. Yes. Jordan is here. I'm very fascinated. Can I see your No. Yes.
So, wait,
Yes.
no.
Alright guys, look up here. If it is cotangent, you only have the choice of going from 0 to pi. Don't tell me negative pi over 4. That is not in there, okay? That's over here. This is not a part of the circle you get to use for cotangent. So it's 3 pi over 4. Alright, let's do secant of 2.
Is that -1?
Yes, I forgot my inverse. Yeah, that other one doesn't work. Inverse secant of 2.
Yeah. Wait, I don't know this. No, I don't.
You can try this, guys. Yes, yes.
I still got it.
No.
Oh, wait.
Yes, yes. No.
Oh, it's the other one. I do that. I put sign instead of sign. Yeah, I was so confused. I remember 2 pi. That's not 3 over 3. No.
No. Yes. Oh, Jordan, what is it? No. Yeah. Jordan, that'd be negative. Yes.
It's an E, hold it up. I don't think that's how you It's 3 over parallel lines. Oh, perpendicular. It's 2 parallel lines on perpendicular surface. It's 2
Okay, guys, think about it. This is the same as if I asked you inverse cosine of 1/2. Okay, they're the same. That is at pi over 3.
I'll get it back. Yeah, everything.
Yeah, it's just like all right, let's try again.
Last test I mean, I don't understand. I always did better than
Yeah. Wrong quadrant. You gotta use that part of the circle for sign. And it wouldn't be negative every time. Close.
So you're missing a vital sign. Yeah, missing a vital sign.
Close. Oh, yes.
You're missing
Close.
something.
Oh, yes. You're good. Sorry. Is that a negative?
Vital.
Your really long fraction line made me think negative.
Yes, because it's negative.
So guys, the way you should think about this, first,
No. That's not a choice. So much here.
negative 5 pi over 6 is not a choice.
No, this is sine cosine of tan. Is that right? I don't know too.
No. Okay, there's not negative 5 pi over 6, but this is cosecant. This is this part. Goes with sine. Did you write that down?
I think I might have.
Yeah. Okay, go to lunch. We'll continue with after lunch.
There's a color teacher for that. What's the color teacher? It's like. No, you're being taught.
I don't know what number I was on, so I'll just turn it on. Alright guys, let's do this. Yeah. Yeah.
Test, do you want those express as fractions?
Wait, what did you fraction?
That's what.
Okay, I'm like, most of the time your radians are fractions, yeah. Most of them will be radians. I'll tell you in the direction which way I want it. If I don't say anything, I want radians. Yes, yes, yes. Radians. Which is easier. I mean, I think you're to the point now where that's, like, second quadrant, isn't it easier to think 2 pi over 3 than 120 degrees?
Is this a VR game?
Alright guys, that one was negative pi over 4.
That's why you see the white stuff. The person that like
Really have to.
that's why you do
I'm still thinking.
Okay. So can you keep playing a game with me? What's happening right now? Good then. I like how your decorations are. No. Yes. Yes. No. Good job. No.
What is it?
Oh, no.
Oh, does it mean two?
No. Yes, my energy here. Okay. Yes, yes. Oh, yes. All right, that one was 3 pi over 4.
Wait, Alexis, did you get a 90 or more?
I don't remember which one we've already done, but that's okay.
What did you get? No way. So it's we go on.
You got like the guessing.
We get slower when it's tangent and cotangent.
Yeah, I'm just saying this.
Yeah, I got catch you. That's how you recruit it.
Yeah, I can-
I didn't even tell you I just said that.
Yes,
Alright, Alex.
yes.
How many days can you teach me?
Yes. You understand why that's
No.
awesome. So this is negative root 3, so it's got to be fourth quadrant. Your choices are first or fourth quadrant.
Yeah, but I thought you made that it would make a side already goes negative.
Inverse just means tell me the angle that has this as the tangent. Okay. If it's negative, that's still telling you like about the quadrant. So yes, yes. All right, that one was negative pi over 3. One more, guys. All right, inverse cotangent negative root 3 over 3. No, like 6 or 7 people are in some choir thing today, so. Yeah.
I can't say.
I would thought that. No, no. Both be wrong in different ways. No. Yes, yes. No.
Mind your own business.
All right, that one was 3 pi over 3. All right, guys, so back to your notes.
Oh no, we have to do all of them all.
We have very little to finish in the notes, guys. You'll be okay, I promise.
I'm good at this shit. I'm not good at Everyone, all of us are optimistic. Every time I'm optimistic, it's like it's impossible. You know,
Hand that up. It's okay.
I said like 480.
It's under here. Thank you.
When did this go?
All right, guys. So, in the practice, let's look at these. So the first one says cosine of the inverse cosine of negative root 3 over 2. So that's a little different than what you were just doing on your whiteboards, right? Like doing a whole bunch of it. Okay, so you do it a piece at a time. Start on the inside. So what is the inverse cosine of negative root 3 over 2? Did you say pi over 6? That's 5 pi over 6, good. You got the over 6, that's good. And then what is the cosine of 5 pi over 6? Negative root 3 over 2. Right, you're kind of like undoing the inverse with the cosine. Yeah, okay. You're just evaluating. Okay, they aren't always going to be the same. So let's try the second one here. Start on the inside. What is the arc sine of 1/2? Pi over 6. And what is the cosine of pi over 6? Okay.
Wow.
Okay, arc sine of 0. We didn't do any zeros on our practice, so 0. And what is the tangent of 0? Think about tangent. Yeah, we know 0. Ordered pair is 1, 0. Tangent is y over x. 0 over 1 is 0. Or think about your graph. You know the tangent graph goes through 0, 0, right? Maybe you know that? I think you know that. Okay, now things get different on number 4. Alright guys, number 4 is different. We have the sine of the arc cosine of 3/5. It's not. Is 3/5 on your circle? No. So, we're going to draw a little picture. Okay? Your only choices for arc cosine or inverse cosine are the first or second quadrant, right?
Yeah.
Okay, and this is positive 3/5. So where am I drawing? Okay, first quadrant. There's your theta, cosine, so adjacent, hypotenuse. What do you know the other side of your triangle is going to be? 4. Okay, remember, if you are doing arc or inverse sine, the whole purpose of that is to give you an angle. So this gives you theta. So you are now doing the sine of theta, which is, from our picture, four over 5. Okay? So the whole point of the inside piece is just to allow you to draw the triangle so that you can then evaluate it at that angle. Okay, this gives you an angle, and then you're evaluating the sine of that angle. So let's draw number 5. Start on the inside. And this one you can probably tell me the answer, some of you, without even drawing. There's my theta. 3, 4. Do I need the other side of my triangle? No. What's secant going to be here? 4/3? Yeah. Okay with that? If it had said cosecant, obviously you'd have to find the remaining side. Yes. All right, last one. Arc sine is 3/2. First, let's think about it. 3 over 2. Does that even make sense? So this is just. Let's rewrite it. What if it had been sine of the arc sine of 2/3? Would you even need a picture? What would you tell me? 2/3. Okay. All right. So you guys are getting the idea.
Every way, it's not possible.
Just hang tight. Okay, so does that make sense? Remember, if you are doing an inverse, what is your answer going to be? Okay, is it an angle or a sine line? If you are doing the inverse sine, inverse cosine, inverse tangent, any of those, what is your answer? An angle. You're getting an angle out of that, okay? And how many answers should you get? 1, right? Okay. When we solve equations, you might get more than 1 answer. So just make sure you understand the difference here in the notation. Does this have an inverse anywhere in it? No. So it's not restricted circle, not restricted range. Does this have an inverse in it? Yes, you should get one answer. You can only use the right side of the circle. Like, the notation is very, very important with this. You have to pay attention to the details. So let's look at number 7 down here. So these are basic trig equations. And I am going to tell you to solve, we're going to add this to the directions, on the interval 0 to 2 pi. Okay, I'm giving you this interval 0 to 2 pi. That's all the way around the circle, right? Okay? And do you see the little inverse in here with any of them? No. So am I thinking whole circle or restricted circle? Whole circle. Okay, good. So what you're thinking about for number 7 there, sine of x equals a half. Going all the way around the circle, what angles give you a sine of 1 half? Okay, there's actually just 2 answers. What are they? Pi over 6 and 5 pi over 6. If you go into the 7 pi over 6, that's done, then it's negative, so that doesn't work. So you guys understand the difference, how you can get 2 answers here and you're going out of the restricted quadrants? Okay. Sam, did you have a question?
Oh, no, I was using my name.
Oh, okay. So number 8. Again, I should get 2 answers for this one. What are they going to be? I heard mumble, sorry. 3 pi over. Yeah, 3 pi over 4 and 5 pi over 4. That's your second quadrant and your third quadrant. Remember, we are now going all the way around the circle here. Okay? You're not going backwards around the circle. You can't give me negative answers. It's just 0 to 2 pi. Normal circle. Okay, let's do 9. What do you think I need to do first before I can solve this? Okay, lots of options there. Okay. Try factoring first, and then you can set your factors equal to 0.
Oh my gosh.
All right, guys, so if I factor out a sine, I'll have sine times sine of x plus 1 equals 0. So okay with that. All right, from algebra, we know we can then set our factors equal to 0. Okay, that only works if it's a 0 on the other side. Yes, right? We know that. The 0 product property.
Yep.
Okay, so sine of x equals 0. Sine of x plus 1 equals 0. So really, I'm thinking about that. So I'm trying to figure out where does sine equal 0. Where does that happen? And we're going all the way around the circle. 0 and pi, okay. And then, Jordan, you want to answer where sine equals to negative 1? There you go. So, all of those are your answers for this one, right?
You also put 2 pi as well.
So, if you look at how I wrote it, I included the 0. I did not include the 2 pi.
Okay.
Okay. Makes sense. Why not?
In my record.
You ready?
Yeah, you can write them together. All right, so then the last one, tangent. Where on your circle does tangent equal root 3 over 3? 5 over 6 and? Okay.